Step into the unknown. Welcome to the quantum room, where science meets imagination.
Have you ever wondered why apples fall from trees, but electrons can be in two places at once? Welcome to the world where classical physics ends and quantum physics begins. Let's break it down simply. What is classical physics? Classical physics is the science of the everyday world. It's what explains why a ball rolls downhill, how planets orbit the sun, how a car moves when you push the pedal. It's predictable, logical, and based on common sense. But when scientists started looking at very tiny things, like atoms and particles, the rules suddenly stopped working. Where it breaks down: in the early 1900s, strange experiments shook up physics. When light hit metal, it didn't always behave like a wave. It acted like tiny particles. Atoms didn't give off just any color of light, they gave off specific ones. Electrons weren't just orbiting like planets, they seemed to pop in and out of places unpredictably. Classical physics couldn't explain these mysteries. Enter quantum mechanics. To explain the weirdness, scientists developed a new theory, quantum mechanics. This new theory told us particles can also act like waves. Energy isn't continuous, it comes in chunks, we call them quanta. The exact position and speed of a particle can't both be known perfectly, thanks Heisenberg. In this new world, certainty is replaced with probability. When do quantum rules apply? So, do quantum rules apply to everything? Yes, but they really matter only when you're looking at atoms, electrons, light particles, photons, super tiny systems. As things get bigger, like humans or cars or footballs, quantum weirdness fades away. Classical rules take over, and the world seems normal again. This smooth shift is known as the correspondence principle. Basically, quantum physics turns into classical physics at large scales. Why don't we see quantum weirdness every day? Imagine you're watching a magic trick really close, everything looks bizarre and mysterious. But step back a little, and suddenly it just looks like regular sleight of hand. That's kind of what happens in nature. Small particles behave in spooky, magical ways. But as they interact with the environment, their weird quantum behavior gets washed out. This process is called decoherence, and it's why the world looks classical to us. Final thoughts: the universe didn't change, we just built better tools to see it more clearly. The quantum world is the universe's backstage, where particles dance to rules that defy common sense, yet power all modern technology.